Hello everybody, hopefully you're doing well. We'll start up with chapter 12, lesson 5, electricity and magnetism. So as you know, all matter is made up of atoms. All atoms in turn are made up of different numbers of protons, neutrons and electrons. Now, although electrons are much smaller than protons, they carry the same amount of electric charge. When positively charged particles, protons, and negatively charged particles, electrons, are equal in number, the charges cancel one another out. So electrons, you know, they spin around outside an atom's nucleus, and they can sometimes separate from it. Now, if a stray electron is lost by one atom and picked up by another atom, then the charges of both atoms change. This becomes positively charged since it lost an electron, and this atom on the other hand gains one electron, so it gets a negative charge. Now, the transfer of charged particles build a series of electrically charged atoms. This is what basically electricity is. Electricity refers to the movement and transfer of the energy of charged particles. The flow of electricity is energy that is available for doing work. So this energy is used to power motors, lights, appliances, and many other devices that we use. So electricity is basically the flow of electrons. Now, when two materials touch one another, electrons can move from one material to the other. This causes one material to become more negatively charged than the other. The material that gains electron becomes negatively charged because it has more electrons than protons. The material that loses electrons becomes positively charged. The transfer of electrons from one place to another causes an imbalance of positive and negative charge. This results in a static electricity. Static electricity is the buildup of a positive or negative electric charge on a material's surface. Static electricity can be provided by many different non-metallic materials. Some, for example, may lose electrons easily, some may not. Now, for example, the atoms in your skin tend to lose electrons more easily than the atoms in the cat's fur. As we can see in this example, if you were to pet a cat, your hand would gain a negative. For example, if you were to pet a cat and your hand is you rub on the cat, it gets a net positive charge, and the cat's fur would get a net negative charge. So what happens then? That petting that cause cat fur to stand on end, because so many strands of hair have the same negative charge. The negatively charged hair strands repel one another. Since they repel, that's why you see that hair just slightly, it wakes up, because they have the same charge. You rubbed your hand, you petted your cat, it got the positive charge, so there's much of negative charge which causes this. This is an example of static electricity. The difference in electric charge produces an attractive force which is similar to gravity, only stronger. Now, static charge, another example is, for example, on a comb. It can make a substance such as, for example, you have papers, a piece of papers, and you rub the comb with your hair, and then you can pull it to the pull of gravity, and it will jump. You see the papers will jump to the comb. Okay, this is also the same example, that the comb got more negative charge, so you'll see that papers which with positive charge will be attracted to that comb. Now, how can electricity jump? Now, have you ever shuffled your feet across a carpet? If so, you may have noticed that if you reach for a doorknob after walking through a carpet, a spark jumped and caused a small shock. This contact between the soles of your shoe and the carpet caused electrons to move from the carpet to you. So electric charge flows over your body and electrons jumps from your hand to the doorknob. Now this spark equalizes the difference between the ratio of positive charge and negative charge. A discharge corrects an imbalance. Your hand is negatively charged, that doorknob is positive charge. You see the electrons jumping from an extra electron. Let us say there were 2 electrons, now imbalance. That electron from your hand jumps over there and makes it a balance. Now discharges are responsible for static shocks. This is an example of a static shock. Now when charged object is placed near neutral object, an object with no net charge, that charge object can affect the overall charge of the neutral object. Let us say like charges within the neutral object, they are repelled, and unlike charges are pulled towards it. This movement can cause an induced charge to form. So an induced charge is a static charge that is caused by the presence of an object that itself has a positive or a negative charge. If a neutral object is affected by the charge of another object and is then touched to the ground, a discharge occurs, as you see, as we took an example of this one, and like charges rapidly drain away. So when the original object is away from the charged object and is no longer affected by its force, the formerly neutral object is left with net positive or net negative charge. Let us say when you rub a balloon on your hair, some electrons leave your hair and are transferred to the balloon, right? The balloon then has a net negative charge now. So if you stick that balloon near the wall with no net charge, the negative particles in the area of balloon will basically do what? Yes, they will, with no net charge, it will be attracted and the balloon will stay there. But after some time, as you see, when the charge is lost by the balloon, it will fall over back. So this is what induced charges are. When a static charge caused by the presence of an object that itself has a net positive or negative charge, either it has a net negative charge or a net positive charge, and it is affected by a neutral object. Such an example of this balloon, when you stick it over that neutral wall, it sticks there unless and until the balloon has that negative charge. When the negative charge will be lost, you will see that balloon will fall over down. So this was the lesson for today. We'll continue the lesson in the next period. If you have any question, please feel free to ask. And thank you for listening once again.